Hi everybody, this is Shiva Biram signing in. In today's session I am going to explain you the RC coupled amplifier and its frequency response. We consider here the RC coupled amplifier for two stages, that is single stage and also for second stage. When you go for second stage, the output from the first stage will be given as input to the next stage. Here the amplification will be done twice, two times. Let me go through the details. These are the objectives that we consider in this particular lecture. So gain and bandwidth of the RC coupled amplifier. Let me brief you what actually gain and what is meant by bandwidth. Gain means it is the ratio of output electrical quantity to the input electrical quantity, and bandwidth is nothing but it is the range of frequencies for 70.70%, that is 1 by root 2 times of the voltage gain in the frequency response curve. So we are going to study about all these things in the coming slides. Frequency response means when these are the characteristics drawn between frequency on x-axis and voltage gain on y-axis. That's about the circuit of the single stage RC coupled amplifier. Let me explain you the circuit components here and also the input and output. Here we give the input signal, and this is the amplified output signal. There is a phase shift of 180 degrees in the output with respect to the input. So why this phase shift is going to be arrived here, that things have been explained in the previous session. If the viewers didn't go through it, please go through my previous videos for this explanation. And here C input is the C in is the input capacitor, which sends only the input signal to the base emitter circuit. R1, R2 and RE forms the biasing circuit. RC and this CC coupling capacitor are going to form the output circuit. Here coupling capacitor is used in order to deliver only the AC signal to the next stage. It blocks the DC component of the signal or the output. And the emitter bypass capacitor, the purpose of this emitter bypass capacitor is it is connected such that the overall effect of this combination, the reactance is going to be decreased and offers a smooth flow to the flow of input signal. That's for this particular circuit. And next let us go for the two-stage RC coupled amplifier circuit. Here we are going to have the circuit of RC coupled amplifier repeated two times. So this is what actually is there, that is going to be repeated here. Similarly, similar circuit. This is the input we are giving here, and same R1, R2 here, R1 and R2, CE, like that. All these things will be the same, and whatever output is there, that will be given as input to the next stage, and the signal will be amplified two times here. That is the output that we are going to give to the next stage, and these are going to form the bias to the base emitter junction and the CE, emitter bypass capacitor. All this the purpose of all these components have been explained earlier. So let me go through the circuit details once again. CE forms C input couples the input AC signal to the base of the first stage, and the CC couples the output of the first stage to the input of the second stage. It transmits only the AC signal and blocks the DC, because capacitor will be blocking the DC. It is the property. You can go for the capacitive reactance formula. Xc is equal to 1 by 2 pi Fc. As the frequency is 0, it offers infinite reactance to the DC signal, and R1, R2 and RE are going to provide biasing and stabilization, and CE offers low reactance path to the AC signal. If you go for the operation, first we give the input signal and it is amplified by T1, and this amplified output of T1 appears across RC, and this output is given as input to the next stage, and it is being further amplified, means 2 times, and hence the overall gain is going to increase further. And if you go for the phase of the output here, the phase of the first stage will be 180 degrees out of phase with respect to the input signal, and in the second stage it will be twice, means 180 plus 180, 360 degrees. It means the output of the second stage will be in phase with the input AC signal, because 360 degrees is nothing but, again we come back to 0 degrees. So let me explain you with the help of the waveforms. This is the AC input we give, and at the output of the first stage we are going to have the amplified and but inverted 180 degrees out of phase with respect to the input, and at the output of the second stage the amplification will be twice, but the phase will be 180 plus 180, 2 times. So 360 degrees we are going to have, which is nothing but 0 degrees, or you can say in phase with the input signal. So these are the things we have studied till now. Now let me explain you the gain and bandwidth of an amplifier. So gain is already we have seen, that is the ratio of output electrical quantity to the input electrical quantity, and bandwidth, it is the range of frequencies over which the gain is equal to or greater than 70.7% of the maximum gain. So frequency response means it is the curve drawn between voltage gain and frequency of an amplifier. So here, in order to consider the frequency response, we consider the following frequency ranges. Lower frequencies, that is less than 50 Hz, medium range of frequencies between 50 and 20 kHz, and higher values of frequencies greater than 50 Hz or 20 kHz. For these three ranges of frequencies, we study the gain values. As this is the frequency response of the RC coupled amplifier, you can observe we consider frequency on x-axis and gain on y-axis. For lower values of frequencies, that is less than 50 Hz, and also for higher values of frequencies that is greater than 20 kHz, we can observe that the voltage gain is going to fall. We shall discuss the reasons why this voltage gain is going to fall for these two ranges, and between the ranges of 50 Hz to 20 kHz, it is going to be constant. It is showing a flat response, means the gain is going to be constant within this range. So the reasons we discuss later on in the coming slides. So here let me go through the bandwidth here. Later we discuss the reasons for the fall of this voltage gain. Here the bandwidth, you can see we are going to draw a line. This dotted line is going to represent the gain at 0.70, 70.7% of the maximum gain. So if this is the maximum gain, this line corresponds to 70.70%, 70.7% of the maximum gain, and this line touches the frequency response at 2 points. This point corresponds to F1 and this one corresponds to F2, and whatever range of frequencies there between F1 and F2 is considered as the bandwidth. Hope it is clear to you. And let us go for the before going for the discussion of the reasons for which the voltage gain is going to fall at lower values of frequency and at higher values of frequency. First of all, let me explain the reactance of the capacitor. Xc is given as 1 by 2 by Fc. So here this is a hyperbola, and it is very clear that the capacitive reactance will be inversely proportional to the frequency. Means if the frequency decreases, the capacitive reactance increases. The frequency increases, it happens in the reverse way, that is the capacitive reactance decreases. First, at lower values of frequency, it is clear that the capacitive reactance becomes more, and hence at the output side, the coupling capacitance, the reactance of the coupling capacitor becomes more. So more signal is going to be dropped, and only a little part of the signal will be given to the next stage, which it is clear that the gain is going to be decreased. And similarly, if you go for the emitter bypass capacitor, here also the reactance is going to become more, which is going to decrease the signal. voltage gain. So these are the two reasons because of which the gain is going to fall. So coupling capacitor reactance becomes more, and so only small part of the signal will pass from one stage to the next stage. And this is emitter bypass capacitor reactance becomes high, and the shunting effect will not be proper with respect to the emitter resistance RE. And higher values of frequencies, what happens, let me explain you. As we know that the capacitive reactance becomes less for higher values of frequency, hence the signal applied will be more. But here because of the lower values of reactance at higher frequencies, the loading effect of next stage will be more on the previous stage, which is going to cause the reduction in the voltage gain. Similarly, the capacitive the reactance of the emitter bypass capacitor also decreases, which is going, because of that there will be more flow of the beta IB, that is the base current. Because of that the base current amplification factor beta is going to fall, which causes the reduction in the voltage gain, because beta is equal to IC by IB. So you can see the reasons here for which the voltage gain is going to fall at higher values of frequency. Between the range, that is 50 to 20 kHz, the gain is going to be constant, because here let me show you what actually happens is when the frequency is increased from within this range, that is from 50 Hz to 20 kHz, the reactance, of course the reactance is going to fall. Because of this fall in reactance, higher the loading effect of the previous stage will become more, which tries to reduce the voltage gain. That is one part. And at the other part, the large part of the signal is coupled as the reactance becomes less. So this causes more gain. These are going to be balanced. One causes lower voltage gain and another one causes higher voltage gain. These are going to be cancel each other and make the uniform gain, means constant. So next, let us go for the advantages. The frequency response will be excellent for this RC coupled amplifier, and inexpensive means the cost will be less and very compact in size, and it provides less frequency distortion. Disadvantages, if you go for the disadvantages, it is having low voltage and current gains. It becomes noisy with the aging effect, and also sensitive to the moisture and the climate effects. Impedance matching is poor, means the output impedance, and there will not be matching between the output and input impedances here. See here at the output set, this is only a few ohms, whereas here this impedance is going to be 100 ohms, so the impedance matching will not be proper here. If you go for the applications, it is going to be used majorly to amplify the speech or music, and also used as voltage amplifiers in the initial stages of PA system, that is public addressing system. So let me summarize the things that we have studied till now. The frequency response of RC coupled amplifier, factors affecting the frequency response, and the advantages, disadvantages, applications, and these are the generally asked questions frequently. Frequency response of RC coupled amplifier, and the gain, why the gain falls at higher frequencies as well as at lower frequencies, and also the advantages and disadvantages of RC coupled amplifier, applications, and all these things are the generally questions which are being asked frequently. And thank you for watching, and please do subscribe to my channel and give your valuable feedback so that I can make more videos for you. Thank you for your listening. This is Shiva signing off.